Okay, so we've got the situation set up here. Okay, we've labelled all the forces and distances, and we meant to then work out the reactions at P and Q. So to start with, I'll say, look, because it's in equilibrium, forces up equals forces down. So forces up are RP and RQ. Forces down then are these two here. So you've got the 2G weight and then the mass of the rod, of course, which is 9G. Okay, so RP plus RQ is equal to 11G. Now I don't know what RP and RQ are, obviously, so I've got an equation there with two unknowns. So now I need to take moments. So if I take moments, say about P, okay, the clockwise then will be, what will I have clockwise? I'll have, this will be clockwise, so about P there, so it'll be 9G times 0.3. RQ will be anti-clockwise, okay, so RQ then times that distance there, which would be 1.4 if I add those two together. And then, of course, this will also be anti-clockwise, about P, so it'll be 2G times 1.2, okay? So then just a little bit of work then to work that out. So 9G will be 9 times 9.8 times 0.3, which is 26.46. RQ times 1.4 plus then 2G, 2 times 9.8 times 1.2, which is 23.52. Okay, so then I can get RQ then, take that over to the side, 26.46, take away 23.52, divide all that then by 1.4. So I get out RQ to be 2.1. And then to get RP, we put it in there. So RP then will equal to 11 times 9.8, 11G, take away 2.1. So we get out to be 105.7. Okay, so quite a lot of reaction there. Okay, not so much at Q. Part B then, it says when an additional mass of 3 kilograms is attached to the point R on the rod is on the point of turning about P. Calculate the distance AR. So basically now we've got this mass here of 3 kilograms and it's added at the end there, okay? And we want to know what this distance is here, X to R, right? But it says it's on the point of turning about P. If this is on the point of turning about P, that means there's going to be more sort of pressure on P, so the reaction there is going to increase. But if it's on the point of tilting about P, it's on the point of lifting from Q. So that means then at Q, the reaction will be 0. So we could say, look, at the on the point of turning, or the point of tilting rather, it's about P, reaction at Q will be 0, okay, i.e. RQ will equal 0. Okay, so reaction will change. Yeah? If you add a mass here, reactions will change to what we got in part A, because it's on the point of turning about P, tilting about P. It's about to lift from here. If it's about to lift from there, there's no pressure on Q, so there's no support, there's going to be no mass there. So that's 0, there's going to be no reaction there. It's a 0 reaction, okay? So if I take moments about P, okay, again, now moments about P, I'll have, this will be the clockwise one, so it'll be 9G times 0.3, okay, that's clockwise. And the anti-clockwise will be these two forces here, anti-clockwise moments about P. That we can just ignore, because that will be 0 now, so we can forget about that. But we need to have these two from P. So the 2G we could start with, that's a distance of 1.2, so 2G times 1.2. Okay, plus then the 3G, now we've got to get this distance right. The 3G will be that distance there. Now if the whole distance is 1.2, and that's X, then the shorter distance will be 1.2 take away X. 1.2 there, take away X. Okay, so we've got that there. And the G's will cancel. Okay, so we have then 9 times 0.3, which is 2.7. 2 times 1.2, which is 2.4. Plus then 3 times 1.2, which is 3.6, and 3 times x will be 3 times minus x, which is minus 3x. So So take it over to the side, you have 3x will equal to, those two added together, take away the 2.7, we get 3.3, so x will equal 3.3 divided by 3, which is 1.1.